format by Kelly Mahoney, Alan White, and Dave Novak. Kelly and Alan are with the Earth Systems Research Lab in Boulder, and Dave Novak is the director of the Weather Prediction Center of National Weather Service, NCEP. Just to remind everyone, the purpose of the forums are to provide exposure for things that may be transitioning from research and development to operations, and our NOAA constellation of test beds is one of the key infrastructure pieces used to do that. The Hydromet testbed is one of those, and we're very interested to see the latest coming out of that, water and precipitation prediction as it pertains to a whole variety of uses, not the least of which is hydrology is certainly of high importance for the Weather Service. So our format, per usual, is 30 minutes of content roughly, followed by a question and answer session. If you have questions, we ask you sort of write them down and have them ready for the Q&A. You can use the raise your hand feature in the GoToMeeting to raise your hand, in which case John will unmute you and you can ask your question directly. Or you can use the chat feature as well if you prefer. And also a reminder, this session is being recorded and will be uploaded to the VLab Forum website shortly after, and you can share that with your colleagues. So without further ado, handing it over to Kelly and Alan, or Alan and Kelly, whoever's going to go first.
This is Alan. Thanks, Steve, for that nice introduction. This is going to be a tag team approach, like Steve said. We're going to start off with our regional implementations of HMT, both in the West, and then Kelly will take over and talk about the Southeast. HMT is a national program, but from our standpoint, we implement it regionally because the different regions have different forecast challenges, different water concerns, and so we'll go through that. So we have to figure out how to forward. Oops. Just slow.
Yeah, I don't know. Sorry. We saw it was advancing. We did see it advance.
Oh, okay. It just didn't advance here. Okay. Well, why study water? It's interesting that in our government there isn't really one agency that owns water, and I think that's because it's such a interdisciplinary science. But a few years ago, we had an interagency planning workshop here on water. And this is one of NOAA's 5 grand science challenges. And then as Don Klein has noted down here in the lower right, there's really a triple threat associated with water as we move through our future because of population growth and economic development, also climate variability and change. And then there's, all around the country, there's aging water infrastructure. And I'm not just speaking about dams and levees, but also bridges that go over our waterways. Recently, there was a service assessment conducted by the Weather Service for the drought in California, and they had a high-level finding and recommendation in this report. They feel that the habitat blueprint and the hydrometeorology testbed are examples of great collaborative interagency programs, and the recommendation was to expand this so that we can promote forecast-based reservoir operations. As you know, many of the reservoirs that are controlled by the Army Corps of Engineers use rule curves that were developed over half a century ago, and there's even legislation being introduced into our Congress to ask them to operate them differently based on forecast information during the wet season. So I'm not going to go through all the programmatics of HMT. All of that's contained on our website, hmt.noaa.gov. You can go there under the About tab. You can read our vision and our mission statement. You can learn about all of our different field programs. If you're very nerdy, you can click on the Publications tab and get access to about 100 different publications that have resulted out of HMT. And then in the lower left, we routinely post newsy items. These are written so that anyone can understand. They don't have to be a hydrometeorologist to understand those. And then on the right, we list some of our major activity areas, mainly focused on precipitation and runoff that happens with that. So one of the things we've learned in HMT is the important role of atmospheric rivers in delivering water to the western U.S. in particular. This is a satellite composite image of integrated water vapor, and you can see these narrow plumes of moisture that are connected, seem to be connected to the tropical reservoir, and these are these atmospheric rivers. And on the West Coast, annually, 30 to 50% of their water comes in just a few of these atmospheric river storms. And if you want to know how much water vapor is there, if you condense that vapor in an atmospheric river, you'd find that it would produce 7.5 to 15 times the average flow of the Mississippi River. So there's a lot of water there. Obviously, all of that doesn't get converted to precipitation. So we've developed what we call an atmospheric river detection tool. This is based on the GFS model and an algorithm developed by Gary Wick, one of our HMT colleagues. And it allows this automated detection shown by these gray dots of atmospheric rivers, both in the GFS integrated water vapor field, but also on the right in the integrated vapor transport field. We found that integrated vapor transport may actually be a better tool to use to identify atmospheric rivers. And then in the middle panel, he shows the core content in terms of what latitude band and where it intersects the coast. At that latitude is shown by the red dot in the middle figures. And this goes out to 7 days, so it's a great tool to look for atmospheric rivers. We're partnering with the state of California because satellites do a great job measuring atmospheric rivers over the ocean, but they're relatively blind over land because of the complex emissivity of the land surface. We're working with the state of California to develop this 21st century observing system that involves several types of sensors, including what we call an atmospheric river observatory, and those are shown by those yellow dots. We have installed one already, and there will be 3 more along the California coast soon. And the GPS sensors are great for measuring water vapor content, which is the fuel that for precipitation. The wind profilers measure the rate at which that fuel is being supplied to create heavy rain associated with these atmospheric rivers. And then for hydrometeorology and mountain areas, we've developed this technology called a snow level radar, which actually measures where the transition is from rain to snow during precipitation. And there are 10 of those installed at major watersheds across California. And then soil moisture networks are in place because the antecedent soil moisture can determine whether a storm is going to produce a flood or whether that storm will not produce a flood, and the ground will take up a lot of the moisture. We've also developed this atmospheric river observatory, which is measuring both the winds and the water vapor. And we've developed decision support type tools from these atmospheric river observatories. And this is a water vapor flux tool that won an award, a bronze medal, back in 2009. And the recent change we've made to it is that we're now incorporating operational forecast models, both the HER and the RAP. But you can also use the experimental versions of those 2 forecast models. And there's a good and bad news associated with this atmospheric river tool is that we found that the forecast models generally do a pretty good job of measuring what I would call the forcing. In this case, it's the integrated water vapor flux that's blowing up the slope of the coastal mountains. And that's shown in the bottom panel by that blue curve. And the dashed curve shows the model forecast of that flux. So the model is doing a pretty good job. But it's not doing as well with the precipitation forecast. And you can see that the T-posts there are the model forecast at 3 hours, and the green bars show the coastal mountain rainfall, and the red bars show the coastal rainfall right at the coast. And you can see that the model is not capturing all the orographic enhancement in the precipitation. And this is something we're going to have to improve if we're going to convince the Corps of Engineers that they can base their operations on forecasts. So there'll be a picket fence of these atmospheric river observatories along the California coast, but the Department of Energy has recently joined the party because they're conducting a wind forecast improvement project this upcoming year in Oregon, and they're funding us to put 3 more of these atmospheric river observatories on the Oregon and Washington coast. So There's no network like this anywhere else in the world, and this is sort of the first line of defense for weather that's moving in on the West Coast. And here's a picture of the snow level radar technology that was developed in HMT. And again, shown in the bottom there, it shows the transition from snow to rain. And this is very important for hydrometeorology because in mountainous areas, because if most of the mountain basin is receiving rain, there's a much better chance for excessive runoff and flooding. In terms of this year and into the future, what HMT is going to work on is we're going to finish our observing the system deployments in California, Oregon, and Washington. We now have a second MOU with the state of California to help fund the operation and maintenance of the network. And there's also a San Francisco Bay modeling project that we're working on with the USGS. We'll continue to publish research based on our Southeast pilot study that Kelly's going to tell you about in a few minutes. We have an MOU with the Sonoma County Water Agency and several projects with them, including installing more soil moisture sites in and around Lake Mendocino, which is one of their critical reservoirs on the Russian River. We're going to continue to analyze the Cal Water 2 data. We had a very successful field program on the West Coast this past January and February. We had 2 of NOAA's research aircraft, the DOE research craft and NASA aircraft, and also the NOAA ship Ron Brown. And the focus of that project was to learn more about atmospheric rivers offshore, but also to study the impact of aerosols on precipitation in California. We'll coordinate with NIMS, the Fisheries Service, on the habitat blueprint projects that are in the Russian River. And we're going to implement AWIPS 2 in-house in PSD here so that we can ease the transition and testing of products before they go into operations. And with that, I'm going to ask Kelly to get up and come over to the other side of the table.
All right, thanks, Alan. So as Alan mentioned, HMT has a national component, but a lot of what we do here at PSC is regional. And so when I joined the HMT group about 4 years ago or so, by way of North Carolina, I happened into some HMT Southeast planning as that project was ramping up. And so I will give a very brief overview summary of sort of the high points of this project, and then happy to come back and talk about more details after we're done here. So NOAA's HMT Southeast project, it can be broken down in 2 parts essentially. There's a pilot study aspect of it, and then kind of describing the main field deployment, and that was focused in western North Carolina and took place in spring 2013, wrapped up last fall. And then there's sort of this other component of it, which I'm sort of dubbing operationally oriented research, focusing on extreme precipitation, sort of forecast challenge identification. And I'll go into more of what we mean by that as in a couple of slides, but it's just to say that the research we conducted as part of HMT Southeast was not limited to our small western North Carolina domain. So a few details on sort of the pilot study aspect of it, or again, the field deployment components. It lasted about 15 months or so, from 2013 to 2014. A large part of this study focused on QPE evaluations, and that's because we were really fortunate to be able to partner with NASA on a ground validation campaign that they were conducting called IFEX. And so part of what went into this was using instrumentation that HMT provided to feed back into our own QPE evaluations, as well as helping NASA to look at their different sort of calibration validation sort of exercises. So the PSD team, or the Physical Sciences Division here in Boulder that was involved, Rob Cifelli, who's in the room with us here, was the project lead. I was the lead scientist. Ellen Sukovich was a researcher working on quantitative precipitation forecasting work. And Ben Moore, who has since left our group, was a really key player in leading some of our research projects. Just to highlight the term pilot study, so this is the Southeast project is distinguished from the West Coast project by a number of things, but also particularly that really we didn't have a long-term plan going into this, which was also the same on the West Coast too. This was supposed to be a pilot study that was happening in coordination with NASA's project. We always said that maybe a long-term project could come out of it, but for now, it was to be a short-term, fixed-term project, and come back to that at the end too, or when we talk about where the project is now. Instrument deployment, just a couple of details here. So for about that 15 to 16 month deployment, centered in Western North Carolina were the bulk of our equipment with 4 profiler sites and 6 surface meteorology sites. All of our sites were accompanied by NASA precipitation gauges and distrometers, again, to help with their validation efforts as well as our QPE work. We were also really lucky to partner with some great local groups. The North Carolina State Division of Air Quality worked with us to help, we helped them restore and upgrade some of the profilers there at Clayton, North Carolina, which is in the center part of the state, and then in Charlotte in the west. We were also able to work with the EPA, the U.S. Environmental Protection Agency, to incorporate one of their new profilers in the central part of the state. So we were able to kind of leverage these projects and work collaboratively to broaden our network, essentially. And all of the data was available in real time and continues to be available for archive download on our HMT, and you can access that via our HMT pages. So research themes, I'm obviously not going to be able to say much about any one of these projects, but I just wanted to highlight some of the major research areas that we've undertaken over the past 2 years or so related to the Southeast. The first is a climatology of Southeast U.S. extreme precipitation events, and that was a study led by Ben Moore that was just published a couple of months ago in Monthly Weather Review. I will talk briefly about that in a moment. We've also looked at sort of a QPF error climatology, and we've done this in a number of different ways, but perhaps most notably been really lucky to support some work at North Carolina State University and work with Marty Baxter when he was on a sabbatical there, and he published a study on QPF errors in the Southeast late last year. We've been looking at case studies of different heavy precipitation events, some focusing on the atmospheric components of what causes the heavy rainfall, and some looking at coupled hydrometeorological forecasts using coupled hydrology and meteorology models to look at that flash flood question with a more integrated approach. Alan alluded to the fact we're also investigating the relevance of atmospheric rivers in the Southeast as well, and that effort is leading to a manuscript draft currently. On the sort of QPE side, folks are looking at bulk microphysical characteristics of precipitation that was observed during our deployment period with the distrometers and vertically pointing profilers, and also looking at how the default NextRad rainfall algorithms compare to other possible ways of doing it. Also working with other partners and within PSC, leading work to look at the performance assessment of different ways of combining radar gauges and other information to look at multi-sensor QPE. So all of that work really is ongoing still, and I did just want to highlight the one piece of work that was just recently published, just grabbing a couple of snapshots without going into a ton of detail. But this was, I think, a really nice piece of work, again, led by Ben Moore and worked on by our team here, looking at really just the large regional variability in the types of events that we can get in the Southeast and how starkly different that is from what we were learning in HMT West on the West Coast, where so much of the precipitation is atmospheric river driven. In the Southeast, Ben's climatology showed very nicely how you can get precipitation at all times of the year for a number of different forcing mechanisms, or via a lot of different forcing mechanisms in a lot of different types of environments. And so what we did there was we broke down a number of past events by not only the typical climatology type of factors, what month it fell in and so on, but also by, I think, more maybe forecast relevant parameters, such as which the size of the event, the spatial scale of the event, how strongly forced it was, what were the Cape parameters, instabilities, the degree of vapor transport going into the event, and did a lot of work breaking that down numerically and also into patterns via composites. So I encourage you to check out that piece in Monthly Weather Review from I think a couple of months ago now, and there's the reference. Wanted to highlight a couple of research to operations or applications achievements of the project. It was a short-term, study, but I think we were able to achieve a number of meaningful connections with the operational community. On about 4 to 5 different occasions, we were able to provide pretty large audience webinars that were able to give forecasters training in using the instrumentation that was being deployed. And just to update, what has turned out to be a really large community that's interested in this project. Over the 15-month or so deployment, area forecast discussions by the National Weather Service mentioned our observations at least 75 times, explicitly over that period. So we were able to make some inroads, obviously, in terms of people developing an appreciation for what those types of observations could do in the forecast or nowcast process. We were able to participate in a number of forecast experiments, which Dave Novak is actually going to talk about more next, trying to continue partnering and maintain a nice dialogue with forecasters from river forecast centers to WFOs to the national centers and so on. We were able to visit a couple of the weather forecast offices and initiate and maintain some good dialogue. And really, especially while the instruments were in the field, we had the opportunity to participate in a number of real-time dialogues via phone and email and group sessions talking about these sort of high-impact events and what the HMT observations were showing. So that was a nice demonstration of partnerships along the way as well. I already talked about a number of these, but again, the Southeast project was, the resources weren't huge for this. And so I think one of the things that we did that was really fortunate was we were able to leverage work with a lot of other different groups so that the sum of what we accomplished was really greater than the individual parts here. And one of them, again, was participating with NASA in the IFEX experiment. We were able to get a lot out of that relationship. Looking at quantitative precipitation reforecast over the Southeast, again, fortunate to find some interested partners at North Carolina State University. We've been able to play a supporting role in CSTAR projects, and again, the QPE validation really entrains a number of different groups in the community, and that work remains ongoing as well. HMT Southeast, where is it now? So the deployment officially concluded in November 2014 when most of the instruments were removed. However, we were also lucky to get Sandy supplemental funding to support a couple or 3 new AROs that were deployed on the Gulf Coast and part of Florida and just south of Charleston. And those are there still and will be there through the end of the year, as well as the site in New Bern, North Carolina, which is on the coast of North Carolina. The Sandy supplemental funding, as well as some support from here, are allowing us to do continued research, and we do plan to get some manuscripts out on that. Some of the work that we're focusing on, again, is identifying the contribution of atmospheric rivers to extreme precip in the Southeast, focusing on some case studies, and again, looking at integrated flood risk. Excuse me. And in terms of the future of HMT Southeast, I think we had a very successful pilot study. We identified some interesting science challenges. Excuse me, I'm losing my voice. Yeah, exactly, get through. And we had, again, a really wonderful, engaged, and enthusiastic community interested in this work. However, we are a regional program, and we can't maintain things in all regions all the time. So this project is definitely in spin down mode currently, but I think we've identified a lot of really exciting future directions should those opportunities ever become available. So that's where the Southeast sits for the time being. And hopefully, if Dave Novak has joined us, he's going to talk about some really the essence of the transitional work at the national scale at WPC.
Yes, good afternoon, everyone. It's Dave Novak here at the Weather Prediction Center. I think Alan and Kelly certainly provided a great overview of kind of the regional implementations of the HMT. Yes, on this slide, what I'm trying to show here is, kind of this spectrum. It's another way of looking at the funnel, if you will, but applied to the HMT PSD group and what we do here at WPC, as well as the academic folks further up the funnel. So on the upper left there, you have these externally funded partners. We have the Next Generation Global Prediction System. There's a number of efforts with OAR, the R2O efforts, our Testbed efforts, and others that are funding academic research partners. Some of that work certainly does filter in and have collaborations with the HMT PSD development group and the regional implementations there, as well as sometimes it goes directly to the HMT here implemented here at WPC, just with that interaction. Based on, as you move further down the funnel, I would say Kelly and Alan's work is higher up in the funnel than what the HMT WPC group is doing here. And so we do have those interactions with the R2O from the Kelly and Alan and Rob, and then moving into the kind of HMT here at WPC. We've had some changes in our staffing. So we have Sarah Perfader, and we have Ben Albright has joined us now. And then we have an advertisement actually on the street right now through the series Cooperative Institute for our NGGPS liaison. So we've got a nice group of 3 experts that will help with these kind of interactive experiments, looking at how does these data sets either on the regional side or on the national side apply to national forecast problems, particularly with heavy rainfall and winter weather. And then, in some respect, then you have kind of the federal workforce that is trying to implement this into operations. So that is our techniques development branch. And then finally, it gets to the forecaster, and what they're looking at, on the screen there in the bottom right. So as you all know, it is a process, but I wanted to just kind of point out where these different points are. I know HMT is kind of complex in that regard. Being distributed, one place in Boulder, we have these regional experiments, we have the interactive experiments here at WPC, and so I think you see throughout all these complementary efforts, we are really spanning the entire forecast funnel. So next slide. So many of you probably are familiar with the interactive experiments. These are largely patterned after the successful hazardous weather testbed experiments, but we've applied it to the flash flood problem and the winter weather problem. So for example, this was results from last year's flash flood and intense rainfall experiment, where we're really trying to improve our excessive rainfall outlook, trying to use kind of objective science with high-resolution models and the neighborhood approaches to identify susceptible areas for flash flooding. Some of the key data sets and findings were the development of a flash flood observation data set that we used for verification. And we found that there was effective probabilistic guidance, that when you coupled these storm scale models and you identified where the model was forecasting rainfall exceeding flash flood guidance and used that in a neighborhood approach, you could get some useful situational awareness displays such as shown on the right. That is the storm scale ensemble forecast of rainfall exceeding flash flood guidance within 40 kilometers of a point. So you can see some hot areas there along the South Carolina and North Carolina coast. And again, this is guidance straight from a explicit convection allowing model coupled with the flash flood guidance. And that could be used to inform the product on the top there, which is perhaps a revamped flash flood outlook or excessive rainfall outlook. So that's kind of our end goal there, is to try to improve that excessive rainfall outlook in the experiment. And just go to the next slide here. We'll highlight the winter weather experiment. This was a few months ago. Again, a number of participants from operations, research, and academia. We explored a number of things, including just improving the deterministic snowfall, but also moving into the day 4 to 7 time frame with probabilistic winter precipitation forecast. And we expanded kind of the remote participation through a daily webinar, and we really did have quite a bit of engagement across the Weather Service looking at these new tools just on that daily webinar. Some of the key data sets and findings were that microphysics-based parameters such as rime factor or percent of frozen precipitation did provide value to the forecaster in terms of both precipitation type and precipitation amount. And we explored this day 4 to 7 winter weather outlook product and some improvements to that, and those were well received, as well as showed skill that we actually could provide some probabilistic forecasts out to the 7-day time frame for winter weather. In fact, so much so that we're going experimental with this winter weather outlook this next season. So there really was a nice kind of R2O impact there of exploring this in the test bed and then moving that into operations, at least experimentally here this upcoming season. So next slide. So just want to highlight, we do have the next flash flood and intense rainfall experiment here, July 6th through the 25th. I should mention it's closely coupled with the MRMS hydro experiment, which will be conducted down in Norman, Oklahoma. Some of you may have seen that as well. They're really focused on the very near term. And then this, our experiment here, the FAIR, is really focused on from a couple hours in the future to as much as roughly 24 hours into the future. So we're using additional hydrologic parameters such as the Atlas 14 heavy rainfall data set. We are looking to improve probabilistic flash flood forecasts and looking at better ways of communicating the uncertainty of flash flooding. We also have a couple of funded partner projects. This is through the Next Generation Global Prediction System, looking at extending forecast skill into the week 2 timeframe for extreme temperature and precipitation forecast. That's clearly of interest. And then moving into verification of weather features in operational models using a cyclone relative approach. So this kind of goes with the National Weather Service's investment in high performance computing. And as we move into the next generation prediction system, how do we extend and improve forecast, and particularly forecast services, across the Weather Service? And then a third competition that we're involved with as well, really HMT-wide, including the folks in Boulder there. We have a number of projects. Unfortunately, at this point, we can't say. Tentative decisions have been made, and the announcements will be coming out soon. But there's a lot of exciting work that's ongoing there that, again, supports these objectives of improving heavy rainfall and heavy snowfall forecasts. So next slide here. So just kind of wrapping up here, particularly from the WPC HMT perspective, we really want to really focus on establishing and improving probabilistic services in the FY16 timeframe and moving out into FY17. With particular focus on the forecaster and tools. These regional demonstrations and the higher order research can certainly inform what we're doing in terms of flash flooding and the winter weather programs here. What's also nice is these experiments are mapped to National Weather Service service areas. So for example, the flash flood and intense rainfall experiment is mapped to the NWS hydrology program. And the winter weather experiment is mapped to the NWS winter weather program. And we have some key products there shown on the bottom, such as the excessive rainfall outlook and the day 4 to 7 winter weather outlook. We're trying to improve and provide new services, and those are nice examples of doing so in those 2 different program areas. Now, on the far right there is perhaps the medium range experiment. We haven't quite solidified that to some degree, but it is, an area you hear Dr. Uccellini, Director of the Weather Service, talk about day 10 forecast and extending forecast as the skill of numerical weather prediction extends. We really need to get our arms around how to do that at the forecast products level and the services level. We haven't quite got organized and resourced in order to do this, but it is something strategically I think we do want to explore. So I think maybe I'll just leave it there, and that kind of gives you an idea all the way from the higher up in the funnel to the regional approaches in the west and in the east, and then kind of this national interactive approach here lower in the funnel at the Weather Prediction Center. So it kind of gives you a sense of this wide spectrum of activities amongst the HMT.
Okay, thank you very much, Dave, Alan, and Kelly. That was really quite a comprehensive tour de force, if you will. Lots of stuff going on, and this is certainly, as was pointed out early on by Alan, such a key area for water, fresh water anyway, falling from the sky, and doing good, doing other things. So. We're now in the Q&A part, so if you have a question you'd like to ask any of the presenters, please use the raise your hand feature, and John Chattel will unmute you to have you ask your question, or use the chat feature. John, do we have anyone?
John Ice has, I think, a couple related questions. The first one is, I guess there was mention of day 8, 9, and 10 forecasts. And he was curious if that was an area that CPC would have expertise in. And then I guess you want to know if the collaboration between WPC and CPC would provide huge benefits.
Yeah, that's probably directed at me. I do think clearly CPC and WPC are going to be and are connected at the hip on that effort. And I would say HMT has had quite a bit of interaction, even Alan and Kelly and Rob's group there with CPC. One of the kind of unique areas, I think, is the reforecast. That it does, CPC has been a strong advocate of reforecast for precipitation, and I think WPC is certainly in the medium range benefits from that, and CPC as well. So, and as you saw, HMT has done work and even contributed to reforecast. So that's a nice example of where you have HMT, CPC, and WPC working together to improve the extended precipitation forecast.
It's great to hear.
That was translated great to hear, says John Ice. Other questions, John?
None at this point.
Okay, so while we wait for some other people to queue up questions, I'll go ahead and ask. So from some virtual lab perspective, well, Dave Novak knows. I'm not sure if Alan and Kelly are aware. We're gearing up this effort across NOAA to collect projects that would be input into a projects database that's being housed in the VLab. And this talk just seemed to be full of potential projects, like just many things that I saw here that looked and smelled like a project. So I guess in terms of, let's like Alan and Kelly, I saw like tools that, like the automated atmospheric river detection tool. It looked like a web-based thing. Is that something that is going to be transitioned into AWIPS-2 and other sorts of things? Do you have stuff that's in sort of a prototype stage that we need to consider moving into weather service operations?
Yeah, that's a great question, Steve. And particularly with that atmospheric river detection tool, that's actually going to be tested in the next FAIR experiment, and in an operational setting like that. And if it's viewed favorably, we would be all in favor for making it, more of an operational product. Kelly, do you want to add to that? Because you're going to be involved in FAIR this time around.
Yeah, so we adapted the tool to work more generally than just being focused on the West Coast, and so a number of improvements have been made, but it's still an iterative process. And so the WPC team that's organizing FAIR now is working with us to figure out a way to have that looked at by a number of operational eyes and the team approach at FAIR. So we'll get some feedback on that, and then probably make, again, some iterations on this end. But I think it's a good tool already, and it'll be a lot better for having some experiment eyes look at it this summer. So hopefully after that, maybe it'll be primed for more.
Okay, just following up on that particular tool, is it basically a situational awareness tool? I mean, the imagery you show, at least for the West Coast, it makes these things look very unambiguous. You know, there's this water vapor plume, and it's so. Are there marginal atmospheric rivers that this tool teases out? Like when you're on the fence, is it really a river? Is it really or not? And does it matter? I mean, so I guess I'm trying to figure out what's the main use of this tool from a forecaster perspective.
Well, like with any feature, you're going to try to look at run-to-run consistency. So with atmospheric rivers, you know, it makes a big difference if it hits one watershed versus another watershed. So you're really trying to hone in on where that atmospheric river is going to make landfall, and also, like you said, the strength of the atmospheric river. Is it going to be a dud? We know that the stronger atmospheric rivers can actually penetrate inland. There's a nice study that's going to appear next month in the Journal of Hydrometeorology, led by Mike Alexander, and Kelly's a co-author. And that paper shows how these atmospheric rivers can get into Idaho, for example, and cause flooding in Idaho. So really, it is a tool, a forecaster tool, really to look at the strength and the location of where the atmospheric rivers are going to hit.
But yeah, I think too, just to speak to, you know, so folks on the West Coast, forecasters on the West Coast have used it in a way that's very specific to them for a number of years, because they know what kinds of orientations and placements and model forecasts are going to be worth paying attention to. In the rest of the country, it is more ambiguous, and so some of the improvements that we've had that we're trying to make kind of incorporate the fact that you know, you need to be sort of flexible in the thresholds and parameters that you set for defining an AR. And does it really matter if it's a quote-unquote AR? Probably not, but really trying to identify a feature, a linear feature of strong vapor transport, and use that as a situational awareness tool to help out. So I think what we're probably going to learn from having people look at this summer is that there's additional things that you can do with that initial capability, whether that's looking at the duration of, you know, quote-unquote AR conditions over a given location, and, you know, whether you couple that with another sort of known trigger or forcing quantity. So that's why we want to have more eyes look at it. We know that it's been useful on the West Coast, but it is a little bit more ambiguous in other parts of the country.
Okay, great. So just one follow-up question, a curiosity, really. So there's a drought in California. We know this. Is it reasonable assumption to think there's been a lack of atmospheric rivers during this time, or is that a bad assumption?
Oh, that's a good assumption. Normally, California will see 5 to 7 strong atmospheric river events in a winter season. They had 2 this past winter. One big one in early December. They thought maybe that would signal the end of the drought, but it certainly didn't. And then there was another strong event in February. But the December event really didn't penetrate inland. It caused a lot of rain right along the coast, but did not cause much snow in the Sierra Nevada, of course, where they rely on snowpack to feed the reservoirs throughout the year. So really, these atmospheric rivers are sort of a double whammy, because they tend to be very warm storms, at least the stronger ones. So the snow levels are much higher in atmospheric river storms than they are, you know, in other situations like with cutoff lows and other storms, other types of storms. So they like the runoff. They like the runoff to fill the reservoirs, but once the reservoirs are full, they don't want too many atmospheric river storms, because then they get serious flooding. But the drought is ongoing in California. The governor has made some new regulations on water use. There's hope that a stronger El Nino will ensue, and there is some correlation with California, but we know for a talk that was given at our lab review last week that really it has to be a strong ENSO for there to be a signal. And really in Northern California, where the largest reservoirs are, there's not as strong a correlation with ENSO as there is in Southern California. So yeah, very good question.
Okay, yeah, well, thank you for that.
Question or comment. Were some of the atmospheric rivers not diverted up further northward into like Washington State and British Columbia?
Absolutely. That's the thing that prevented these from reaching California was that monstrous ridge that just stayed in place seemingly, consistently throughout the winter, and that causes these atmospheric rivers to curve to the north. And yes, so there were places in Canada that got a lot of rain, but of course, in Whistler they don't want rain, they want snow, and these atmospheric river events are so warm sometimes, Whistler won't even get snow out of it.
Really? Wow.
Okay, thanks, Alan. John, do we have other questions?
Yes, Paula Davidson, who I've unmuted in case she wants to add to my question that she submitted. She wants to know, and this is for Dave, a bit more about plans for testing day 8 through 10 forecasts.
Yeah, really, I think Weather Service-wide, we're striving to, but admittedly, I did not hear that we're really going to move in this direction very quickly. I do think, the one area we are getting some resources and funding, as you saw that project by University of Albany, of starting to look at some of the science of these extreme temperature and precipitation events in that time frame. So that certainly helps set up the, some of the science of how to do this. But I think it's going to be a few years off, certainly. So we're kind of at that, towards the top, or at the higher end of the funnel at this point on that kind of 8, 9, 10 day time frame. And it's going to take a while to get lower and lower down the funnel to where you have a forecaster looking at a screen that says day 10 on it.
Okay, great. Paula, did you want to follow up with another question?
Am I muted?
Yes, you are. We can hear you.
Oh, she just muted herself.
Oh, you just muted yourself.
Can you hear me now?
Yes.
Okay. So part of that, I guess, is the question is, how are you structuring that search for most appropriate products in the 8 to 10 day range? Are you doing some more systematic search, or are you looking at opportunities that present themselves?
I think that's a great question. Jeff definitely jumped on opportunities. The NGGPS was a great example of that. At the same time, there are continuing, just involving science in that time frame, especially as the models continue to improve in their skill. As you might know, the guess, I think, almost approached 9 days for the 500 millibar anomaly correlation. So there does seem to be, some signal there that the models are getting at least the mass fields correct that far out. But so admittedly, to the time being, it's just been jumping on opportunities. I would certainly welcome, a more structured approach to that. Working through the ST&I office, we did have a proposed milestone, did not make the FY16 cut at this point. So, and I completely understand that, in terms of requirements and what, as a weather service, we need to do corporately. But I think we need to keep putting it proposed up there for ST&I to kind of think about how we can start to move this forward to get out to day 10.
Okay.
Thanks.
John, other questions?
That's the last one on our list at the moment.
Okay. A question on the atmospheric river observatory. So are those permanent, both in or intended to be permanent in California as well as the southeast?
The funding for the ones in the southeast was really coming from the Sandy Supplemental. Because they're not that expensive to operate and maintain, and there wasn't a lot of tropical weather last year, we decided that we would leave those in place for another tropical season at least. And then the other network on the West Coast is meant to be long-term. You know, we haven't figured out every detail on how we're going to operate and maintain them, you know, well into the future, but they're meant to be long-term deployments.
Okay. All right. Very good. Any other questions in the room? Good. Any more questions online? No. All right. Well, I want to thank our presenters, Alan White, Kelly Mahoney, and Dave Novak for this really informative session. A lot of stuff going on, and like I said, I hope to see projects that are related to this being input into the projects repository in the VLab so that we can share this and track the progress of the various things as they become more technically and scientifically mature. It really seems there's a wealth of things here that you're working on. So thanks again. I want to remind everyone for our upcoming schedule for the VLab Forum. So in June, we're going to get an update on the Impacts Catalog project along with the IRIS and INWS update. This is a big transition project, moving that into the NCEP IDP web farm. July, we're going to return to the National Blend of Models to hear from Dr. Tom Hamill about the science behind the multi-model precipitation forecast that is being used in the blend. In August, we're going to hear about the Extreme Precipitation Forecast Improvement Project, which is, I think, a field-driven project led by Joshua Sheck, so related very much to what we're talking about today. So those of you who are the PIs here for the HMT probably want to dial back in for that one. And in December, way out ahead, we're going to hear about another field-driven R2O project, the Damage Path Toolkit, also led by Joshua Sheck and Paul Kirkwood. So that's what's on tap. I want to thank everyone, and a reminder that John, as soon as we can get this up, we'll have the recording of this presentation up on the VLab Forum website. So thank you, everyone, and see you next month.